Graphing inequalities. So in this video, we're going to be talking about graphing inequalities on number lines. But before I get into that, I'm going to introduce some new symbols. As you can see over here, these symbols look almost exactly like these symbols, except there is a line at the bottom. Now, whenever you see that line underneath an inequality symbol, it simply means that we're saying that whatever's on that side might be equal to whatever is on the other side. So, let's just look at these symbols right over here. These are the symbols that we saw in the last video. Whatever's on the side with the point is less than the other side, and when I say less than, I mean smaller. It's just a fancier way of saying smaller. And whatever is on the side with the mouth is greater than the other side. And when I say greater than, I just mean bigger. It's just a fancy way of saying bigger. Greater means bigger, and less means smaller. Now, the same thing applies over here with these symbols, except since we also have this bar over here, we have the additional phrase, or equal to, which means that whatever is on the side with the mouth will be greater than or equal to the other side, and whatever's on the side with the point will be less than or equal to the other side. Let's look at some examples. Okay, over here you can see I have the variable x, I have an inequality symbol, and I have the number 3. Now, since x is on the side with the mouth, that means that it is bigger than 3. It is greater than 3. So I don't know what x is, but since I know that it's greater than 3, it might be 3.1, it might be 3.7, it might be 4, 5, 6, 10, a million and a half. It could be any number that's bigger than 3. How would we graph that? Well, what we would do is draw a circle over 3. Now, that open circle means that x is not equal to 3. Later, you're going to see we're going to close the circle if it might be equal to 3. But we know that x is strictly greater than 3. It can be any number bigger than 3. It could even be 3.0001, but it cannot be exactly equal to 3. So we're going to draw an open circle over 3 and then shade everything to the right of that circle. Now that indicates that x might be 3.7, it might be 4, it might be 4.5, 5.1. It can be any number. It could be 6, 7, 8, 9, 10, a million, 2 million. Any number bigger than 3. Over here, we see that x is on the side with the point. So that means that it is less than 3. So we're going to put an open circle over 3 and shade everything that is less than 3. So we don't know what x is. Again, this doesn't mean that x is all of these numbers at the same time. It's only one of them, but we don't know what it is, so we're shading all of them. X might be 2, 1, 0, negative 0.5, negative 3.8, negative 5.2, negative 6, negative 7, negative a million, whatever. It's just something less than 3. Now over here, we see that x is greater than or equal to 3. So in this case, x might be equal to 3. So what are we going to do? We're going to shade the circle in, and then shade to the right. So we don't know what x is. It might be 4, 5, 6, 7, 8, whatever. It might be any number that is bigger than 3, but it also might be 3, which is why we're going to shade the circle in above 3. And finally, since here x is on the side with the point, we know that x is going to be less than 3, but it also might be equal to 3. So again, we're going to shade in this circle because x might be equal to 3. We don't know. And we're also going to shade everything to the left of 3 on the number line because x might be a number that is less than 3. Now, the variable, in this case, x, I like to use the letter x for a lot of things. It doesn't have to be x. It could be y or z or a or b or c. I happen to like the letter x. Anyway, the variable does not always have to be written on the left side. It could be written on the right side. And it's just as easy. If it's on the side with the point, then it's smaller. If it's on the side with the mouth, then it's bigger. In this case, we can see that x is less than, since it is on the side with the point, it is less than -4. So we would put an open circle above -4 and then shade everything to the left of that circle. X might be -5, -6, -6.1, -12.3, anything that is less than -4, but not equal to -4. X is not equal to -4, which is why we did not shade in this circle. Over here, x is on the side with the mouth, which means it is bigger. It is greater than -4. So we're going to put an open circle above -4 and shade everything to the right. So we don't know what x is, but we know that it's bigger than -4. So it might be -3. -3 is bigger than -4 because it's further to the right. It might be -2. Again, -2 is bigger than -4 since it is further to the right. It might be any one of these numbers, including a decimal. It could be maybe 1.6. We don't know. Okay, over here, we see that x is on the side with the point, so we know that it is less than or equal to. Since we have this bar underneath, x might be equal to -4. Now, how do we show that on a diagram? We would shade in -4 to indicate that x might be -4. And since it's less than it, we're going to shade everything to the left. And over here, at this point, you probably know exactly what this is going to look like. X is on the side with the mouth, which means that it might be bigger than -4, but since there's this line here, x also might be equal to -4. So we are going to shade in the circle above -4 and shade everything to the right because x is greater than or equal to -4. And that is this. I mean that.